You're listening to episode 21 of The Star Spot for Friday, January 11th, 2013.
I'm Justin Trottier, and I'll be your host at The Star Spot. The Star Spot is a space-themed podcast that focuses on all aspects of astronomy and space exploration. Episodes feature interviews with guests of wide-ranging backgrounds: scientists, engineers, educators, artists, politicians, and business people. Topics are similarly broad, from the latest space mission to how the universe began, from why humans explore to how we can make exploration economical. We'll also include a segment called Current in Space, bringing you reports on news and developments that may interest the space enthusiast. Today I'm joined at the Star Spot by Dr. Stuart Clark, a combination astrophysicist and novelist. We'll discuss his stories about the great minds of astronomy, Kepler, Newton, Galileo, Einstein, and others, and how conflict really propelled forward our understanding of the universe, conflict between individual scientists like Newton and Hooke, and conflict between worldviews, like Galileo and the Church. But first, here's what's current in space.
Hello, my name is Jesse Mintz.
I'm Mallory Warren, and this is what's current in space.
2012 was a banner year in space exploration. From all the drama and excitement of the Mars Curiosity rover, the exquisitely choreographed 7 minutes of terror landing, the possibility of the discoveries that lay ahead, and the sheer fact that a mobile laboratory made on Earth is at this very moment cruising around the inhospitable Martian landscape, to the recent images from the Hubble telescope of the most distant stars and galaxies yet glimpsed. It's been a busy year in space.
At the risk of minimizing these important events, though, 2012 was the year of the exoplanet. The first planet discovered outside of our solar system was announced in 1992. From the list of planets beyond our sun grew slowly, as an average of 3 exoplanets were discovered each year. With improved techniques, though, new planets are being detected nearly every week, and the tally at the time of this recording stands at a promising 854 alien worlds. Thanks in large part to NASA's Kepler mission, which was launched in 2009 with the specific goal of surveying the Milky Way for Earth-like planets, we are living in the golden age of exoplanet discovery.
Detecting a planet is no small feat. Earth-sized rocky planets, even supermassive gaseous giants like Jupiter, are too tiny and far too dim in most cases to be observed directly.
Instead, scientists rely on several other methods of indirect observation to find evidence of planets orbiting stars. The most fruitful method to date, and the one employed by the Kepler mission, is also the most rudimentary, waiting for planets to pass in front of their parent stars, causing slight but revealing dips in starlight.
This is really incredible. Think about it. The Kepler telescope is right now hurtling through space, taking photos of a patch of sky with up to 150,000 stars in it. The stars are anywhere from 10 light years to hundreds of thousands of light years away, and yet the images are so precise as to reveal the telltale 1% dip in luminosity that reveals an exoplanet.
So where does that leave us on our quest for an Earth-like neighbor, and ultimately for life?
The latest evidence from Kepler suggests that 17% of all sun-like stars in the Milky Way host a rocky planet. And since the Milky Way is home to about 100 billion stars, those numbers suggest that there are at least 17 billion rocky worlds out there for us to discover.
17 billion? I like those chances.
Let's not get ahead of ourselves. It's not, of course, that simple. The planets, aside from being rocky, have to exist in the Goldilocks zone, the perfect sweet spot, orbiting neither too close nor too far from their parent sun, allowing for liquid water on the surface. We will have to observe the atmospheres and compositions of these exoplanets in greater detail before we can draw any conclusions about their suitability for life. Finding Earth 2.0 will have to wait a while yet.
Take heart, though, listeners. We're well on our way, and 2012 witnessed the discovery of some very promising candidates. But before we get into all that, a little forewarning. While these planets hold our best chance yet at finding life, their names fall a little flat.
With that in mind, let's go over some of the most exciting discoveries from the past year. Let's start at the top. The most promising discovery from the past year was undoubtedly Gliese 667cc. Announced in February, the rocky planet is part of a triple star system in the constellation Scorpius. Clocking in at a short 22 light-years from us, and with a mass 4.5 that of Earth, It is designated as a super-Earth. Most exciting of all, though, the planet exists in that Goldilocks habitable zone of a star, with a temperature that would allow liquid water to exist on its surface.
A close second is the Tau Ceti star system, located in the constellation Cetus. Discovered in December, the Tau Ceti system supports 5 planets. Of the 5, 2 of the outer planets, Tau Ceti E and F, fall within the habitable zone. Only 12 light-years from Earth, the Tau Ceti planets are the closest potential habitable exoplanets that we currently know of.
While they may be the closest habitable planets, they are not the closest exoplanets in general. That designation belongs to the planets within the Alpha Centauri system. Alpha Centauri BB orbits its star far too closely to support life. Hugging its star only a few million miles away, 10 times closer than Mercury to our own sun, it is far too hot for liquid water. But at a mere 4.3 light-years from Earth, it opens the possibility of the existence of other exoplanets in our galactic backyard.
Rounding out the list for most exciting new exoplanets discovered are those orbiting Kepler-34 within the constellation Cygnus. The planets in the system are both gas giants and therefore unlikely homes for life. They cracked the list, though, because of the stars they orbit. Kepler-34 is actually a binary star. Once thought of as too chaotic for stable planetary orbits, the planet's discovery last year demonstrates that worlds with 2 suns, picture Tatooine from Star Wars, may in fact exist. And considering that new evidence points to the prevalence of sun-like binary star systems throughout the Milky Way, this discovery opens up a whole new arena for the search of Earth-like exoplanets and, ultimately, for life.
And that's what's current in space.
I'm very excited to be joined today by Dr. Stuart Clark. Stuart Clark, PhD in astrophysics, is Fellow of the Royal Astronomical Society, former Director of Public Astronomy Education at the University of Hertfordshire, and a writer for New Scientist, The Guardian, and BBC Science programs. Clark is the author of over a dozen books, including a trilogy of novels that dramatize pivotal periods in the development of our understanding of the universe, incorporating as characters in the plot the scientists at the center of discovery. These books include The Sky's Dark Labrynth about Galileo and Kepler, The Sensorium of God focused on Isaac Newton and his contemporaries, and the forthcoming The Day Without Yesterday on Albert Einstein and George Lemaitre. Thank you so much for joining us here at the Star Spot, Dr. Stuart Clark.
You're very welcome, Justin. It's a real pleasure to speak to you.
I appreciate that. Right off the top, I wanted to ask you a little bit about your interesting background, because you've transitioned from astrophysics and research into writing and talking about science, rather, to the public through journalism and through other avenues. Why did you decide to make that transition?
I've always been fascinated with the night sky, and I've always been fascinated by storytelling as well. And so initially I followed a path to become an academic astronomer and loved what I was doing, the research I was doing and the teaching that I was doing. But in all that time as well, I was also trying to write articles for magazines. And in fact, throughout my PhD, I had been funding my research by writing. And what I'd actually been writing was the video sleeves for Star Trek videos over here in the UK. So I was always sort of interested in writing and telling stories, and gradually I sort of started to think, well, perhaps you can tell true stories with the same kind of panache and the same strong narrative drive that most people apply to fiction. And so I decided that that was where I was going to go and what I was going to try and do.
And how has your previous work in the physics community, in the research community, how has it made your some of your writing, especially with fiction and novels, how has that made that writing deeper in terms of your ability to explore a scientific topic?
It's absolutely essential for me, because I like to get into those areas of science that perhaps somebody without specialist knowledge wouldn't ever go near. And so I like to be right on the cutting edge, perhaps in fundamental physics questions or in the most distant and sort of the weirdest sounding cosmology, and try and find ways to bring those completely down to earth. There shouldn't be a reason why a scientist or the science that a scientist does can't be explained to somebody in the street. And so I try to find those ways to do that.
I want you to tell me a little bit about a trilogy of books that you've written. The first one being the Sky's Dark Labyrinth, and these are rather unique. They tell a story or a set of stories related to the achievements of scientists discovering the remarkable universe in which we live and our place within that universe. But you tell the story through the lives of actual people that existed historically. Why did you decide to take that particular approach? And when you answer that question, could you maybe refer to a few of the lives of the scientists that you explore in these books?
Yes, of course. The Sky's Dark Labyrinth trilogy began because I was interested in telling the story of the history of astronomy, because I started to become extremely interested in why do we believe some of the things that we believe about the universe today. What is it from the path that astronomy has taken over the centuries that now leads us to sort of various fundamental ideas about the universe, and how science developed through that, how we rationally investigate the natural world and the wider universe around us. And so I was wanting to try to look at that, so effectively tell the story of science and astronomy from the point of view that it's a cultural endeavor, that it's not something that's separate from society and culture and financial troubles, economic things, and in looking at that history to try and bring some of that into these books, I started to realize that the stories were so rich, that the times in which these great turning points in astronomy took place were so important, and that the characters, the real characters like a Galileo, Newton, Einstein, they were such larger-than-life characters that to dramatize them, to use the trappings of fiction in order to truly bring them to life and to try to get into what they were thinking and feeling, not just describing what they were doing, was actually the way to tell this story from the most human perspective, and to try to bring this story in its most palatable, entertaining form to the widest possible audience.
Well, this provokes a number of follow-up questions, because if you're telling a story about an Isaac Newton and his contemporaries, for example, is the story you're telling, is it a science story, or is it a human story, or is it some kind of hybridization of the two?
I suppose it's a hybrid, in the sense that these are books about scientists. They're novels, they're stories based on true stories about scientists. And so, of course, the work that they do comes into that. You know, it would be ridiculous to try and write a novel about an astronomer, and that astronomer is never seen at the eyepiece of the telescope, for example.
Right.
And so you have to find the story that makes those observations completely crucial to the plot. And when I looked into the stories to see the way that, say, Newton was working in order to try and bring together a wide breadth of knowledge about movement of things on the Earth and movement of planets in the solar system, and how he tried to meld those together into a unified idea, whilst at the same time he was trying to find, if you like, the secret of life itself through his alchemy. And he was also fighting against what he perceived to be a Catholic plot to try and re-Catholicize England and bring England back under the control of the Pope in Rome. So all of this just spoke to me and said storytelling, novel, and great characters, great action, and intriguing and enthralling plot lines.
I was going to ask you another question, but as an aside on that, would you say that there are quirks in the personalities of some of the individuals you explore, like in this case you're referring to Isaac Newton, that really compelled the direction in which he took his science? In other words, would the scientific accomplishments that you're exploring, would they have as easily happened perhaps a few years later under some other incredible mind, or was there something peculiar about those people that made it inevitable that they would be the discoverers of, in his case, the theory of gravity?
Yes, I think you're right in the latter case, that these people were such driven individuals. Newton, for example, in the first book, which it's partly the story of Galileo, but at the same time there was the German mathematician Johannes Kepler. He was working as well, and there, in the case of Kepler, it's his drive, his unquestioned belief that God himself has given him an epiphany that the movement of the planets can be described with mathematics.
Right.
And without that drive, that belief in this divine inspiration, and how Kepler follows this doggedly for decades as he pulls together observations, as he sticks rigidly to his Protestant faith, where he's being driven out from city after city for that as well. And yet never does he deviate from wanting to understand the movement of the planets, when the easy solution to all his problems is just to give up on that. And so I think without these people, these paths to knowledge would have been much longer in coming.
In looking at an individual like a Kepler, and in looking at his own faith tradition and the faith tradition of the community in which he's growing up, can you comment, and this harkens back to something you were talking about, the cultural mosaic, how much do cultural or even religious values play into creating a character who exists within an environment that he believes, in the case of Kepler, in the existence of laws of nature, perhaps handed down by a god? I mean, how much is in this case, the monotheistic cultural background, how important is that in creating a kind of attitude that would look for these kinds of laws?
I think in this sort of early part of, or this part of astronomy, this sort of 16th, 17th century astronomical tradition, it was virtually essential, and they were looking for meaning, they were looking for order, and they were looking for these things in order to understand more about God's creation. They were effectively looking for these things in order to glorify God. Even there's a suggestion in some of the references that these characters left behind. Even the suggestion that if you can discover this knowledge, then you have in fact retrieved knowledge that was lost during the fall of mankind. So in the casting out of Adam and Eve that they believed in. So that was the point at which we lost our understanding and our ability to sort of live at one within the universe. And so by regaining this knowledge through the use of equipment like telescopes and microscopes, we could atone almost for original sin. And so science, in that sense, became a route almost to salvation.
So you're at one time conveying scientific information in this trilogy of books, but you're also telling a very human story of exploration and discovery, which is, not even just a scientific story, but it's a human drama as well. And the one in particular that I'm most intrigued by is the story around Galileo and, of course, the famous Trial of Galileo, which in recent years, there's been a reflection on what aspects of our understanding of Galileo's feud with the church did we possibly not get right from a historical point of view. What kind of discoveries did you make as far as shedding new light on our understanding of that famous trial that's characterized as sort of science versus religion? Because I know you did years worth of reading of original documentation and as much as you could get your hands on. What kind of discoveries did you find on that topic?
Yes, it's a fascinating story. It's quite nuanced, and I would say that there are a lot of historians out there that are really understanding these nuances as well, and have written sort of academic treatises about all of this. And it appears more to me that this was a power struggle. It didn't necessarily reflect a sort of science versus religion aspect so much as it reflected somebody trying to communicate with the general population without going through the necessary Vatican censorship channels.
Right.
So Galileo wrote his famous book about the movement of the Earth in Italian so that anybody could read it. I suspect that if he had written in Latin so that only scholars could have read his work, he wouldn't have been in quite so much trouble. And also, it seems as if he was told that this was an acceptable thing to do so long as he didn't assert that the Earth absolutely moved. If he had sort of said, well, if we just think of the Earth as moving, and this allows us to make a bit more sense or comprehend this a bit better, I think he would have been all right. But the actual fact that he said, no, actually, in truth, this is not just a sort of little mathematical trick to get the right answer, but the Earth actually moves through space. And he believed that he had evidence in the tides, for example, that proved that that the Earth moved.
Right. It was the challenge of the world view, or the view of reality, as understood by the minds at the time, that got him into more trouble, rather than his, establishing a new mathematical method for calculating things.
That's correct. So it was just it was the threat he posed to sort of the power structure of the day by saying, no, I know more than you do.
In 2 of your 3 books, you have one fictitious character, but in one of the 3 books of the trilogy, you don't. Which book don't you need a fictitious character to tell your narrative, and what's different about that story?
Yes, I didn't need a fictitious character in the 3rd book in the series, which is called The Day Without Yesterday. And that's the story of Albert Einstein and a Belgian priest and superb mathematical physicist called Georges Lemaitre. And there, the information that was available was so complete that I could just see the narrative through this. And yet, when I was doing the Galileo story in Skies Dark Labyrinth and the Newton story in the Sensorium of God, in both of those cases, there were things that were missing. And so what I decided that the best way to address those parts that were missing was to invent a character. So in the 1st book, that's a cardinal called Cardinal Pipe. And in the 2nd book, that's a character called Winslow, who's a civil servant. He's a spy master, if you like. And that way I could sort of signal to the reader that every time those characters were in the narrative and driving things along, this was speculation on my part. I figured that every scientist knows that you go and take observations and you have your data points, and then you extrapolate the smoothest curve between all the data points. And so that's what I was trying to do here.
It's a clever way to sort of personify a bit of our ignorance, right, about a historical event or incident. The third story that revolves around Albert Einstein and Georges Lemaitre, the one that you're talking about now, I've always been really fascinated in this narrative by Lemaitre and by his careful differentiation between the Big Bang, which he was a part of theorizing the Big Bang must have happened, and the idea of biblical creation. The Pope at the day wanted to take the idea of there being a first light, as he would refer to it, as evidence of biblical creation. But Lemaitre, who was a priest, and I guess answered to the Pope in that sense, he didn't like that the Pope would do that. Why was that? What was the distinction for Lemaitre?
Yes, this was the really, really clever part about it. And in a sense, it's what ties the whole three books together as a trilogy, because we begin with Galileo and the Pope and this sort of fracture that happens, and then we reach some sort of resolution centuries later with Lemaitre. So essentially, what Lemaitre came to the conclusion was that there was, if you like, a brick wall that you couldn't cross between science and religion. And religion was based on belief. It needed faith. It did not need evidence. And science is based entirely on evidence. Any piece of scientific evidence is a measurement, and the measurement itself is something that locates an object in space and time. So the Big Bang was the moment in the universe at which space and time began. That was therefore the moment at which science was possible, if you like, or the time in the past that you can only go back so far to with science and with measurements. What happened before the Big Bang is therefore something that science, according to Lemaitre, can't touch. So the fact that there had to be the beginning of space and time to Lemaitre implied that there was perhaps something beforehand, and that was where God was to be found. But you can't approach that with science. And so this was, if you like, his justification for how you can be a scientist and still have a religious belief as well. And he did. You're exactly right. He went to see the Pope and to explain this position to him. And from what I understand, that now forms the basis of the Catholic Church's position about the difference between science and religion.
These kinds of personal interactions, the Lemaitre going to see the Pope, I mean, a lot of people have this impression that science is cold, it's inhuman, scientists work in complete isolation from each other and the rest of the population, but it's so not true. And I mean, another example, perhaps we can get into from your second book, The Sensorium of God, revolves around the relationship between Newton and his contemporaries, and especially his feud with Hooke. Can you talk a little bit about that, and again about the idea that science is really, in a sense, about these kinds of relationships, right? I mean, Newton and Hooke really, I guess they didn't bounce ideas off of each other. I don't think they were very friendly, but in a way they reacted to each other's ideas, and it really propelled the scientific awareness that those two men were embarking upon forward a lot faster than it otherwise would have.
Yes, absolutely. So you're absolutely right. They didn't bounce ideas off each other as such, but they tried to provoke each other and tried to sort of score one-upmanship points on each other, and that completely drove along the science. There's some reason to believe that Newton developed his original ideas about motion and gravity itself, and sort of came back to those and started to put them into precise mathematical form, just as a means of getting one over on Hooke. So the fact that he could now do something that Hooke couldn't do seemed to have been the spur to get him to look at this. And once he started on this problem, he said he would gladly get to the bottom of it before he published a single word, and that's what led to his great work, I think the greatest work of science, which was the Principia Mathematica, and this idea of the laws of motion, his laws of motion, the law of gravity, and sort of how you rationally investigate movement.
One of the great debates within historical circles, of course, is whether history is made by great men or women, standing almost outside of the flow of culture and time, or whether these supposedly great people are the product of their time and in that sense inevitable. I mean, you've done some compelling research and writing related to the accomplishments of great scientists. So if we were to look at that debate as within the rubric of scientific accomplishments, can you shed some light on how it would play out there? Is it about great people, or are they products of their time?
I can see the arguments for both, actually. I suppose if I really, really had to sort of lay my cards on the table, I would probably be edging towards them being products of their time. Having said that, they are clearly great minds as well. But I don't think they work in isolation. There is an element of that in the sense that when people come up with new ideas about things, there's a sense of isolation there because you're not thinking in that mainstream of the ways, and this proves to be the left turn that you need. But the questions that they're always trying to answer and that they apply their great minds to are always products of their age. So the movement of the planets in the night sky, for example, that was a test of how well you could make a calendar and that you could make ephemerides of the planetary movements in order at that time to do astrology better, to understand more about what the future was going to give. So Kepler, looking at ways to understand the movement of the planets, was absolutely critical to what they thought they needed for the purposes of astrology. And so in that sense, these questions are always in the air and lots of people are looking at them. And so it's a product of the culture and the society at the time. But then a great mind comes along that sees things just differently enough that they can make a breakthrough and take you down a path that no one else had anticipated.
Do you think you could write a story like this about more modern scientific exploration, specifically, let's say, quantum mechanics or even string theory? A lot of people would probably say no because things are so complicated now, it's hard to see how there could be a one great mind like a Newton or an Einstein who would be so uniquely qualified that they would, outshine their peers in a way that those two individuals did. Now things are done by massive groups of scientists across the planet using computing power largely, that sort of thing. Do you think the way in which science is done and the complexity of the scientific problems in the current era has changed so that a book like the three you've written might not be as possible, looking at, again, say, quantum mechanics or string theory?
It's a very, very good question, and it's almost in the forefront of my mind at the moment because the trilogy is now finished. So the third book will be out this year, and so I'm thinking about what else to do. And thankfully, the books have been so well received that more fiction based on science is a route open to me, and it's very difficult to know because, yes, science is done by these huge and massive groups in the sort of modern world. But one thing that I learned researching these books is that although the groups of people weren't as large in previous centuries, there was always a mainstream ideas of how you made progress, and people all adhered to the direction in which they thought research or the perpetuation of knowledge was going. And then these mavericks like Kepler and Newton came along and took inspiration from places which were not really even very scientific, for example. So Newton took some of his inspiration from the discipline of alchemy and trying to understand what a living spirit was. And in a sense, that gave him a way of thinking about the force of gravity that was completely different from all the other philosophers around at the time. So with that in mind, in a provocative way, maybe the next big advance, dare I say it, is not going to come from these huge groups, but some sort of maverick that just comes up with a really out there idea, and then suddenly we see how it can be applied, how we can see things differently or in a way that we have yet to anticipate, and we see a new path to understanding open up in front of us. Until that person comes along, of course, I don't have any fodder for a book of that kind.
Gotcha. In our last few minutes, I just wanted to change gears and talk to you a little bit about the blog that you write for The Guardian called Across the Universe. Just tell me, firstly, are there any particular themes, sub-themes, I should say? Obviously, the theme is astronomy and science, but any sub-themes you like to focus on, or are you more commenting on sort of current affairs in science and astronomy?
To an extent, I'm commenting, sort of comment and analysis on things that are happening now in astronomy. And I have to say that The Guardian, give me great scope to pretty much do what I want out of it. So I have some pet themes, and one of those pet themes is to look at where I can see resonances with history in what's going on in modern science. So I like to try and find those to look at. I like to try and put things in context. For example, the recent flyby of this potentially hazardous asteroid Apophis, and just keep sort of up to date and hopefully allow people to make more informed judgments of what's going on in the world of astronomy.
One of the more recent columns that I saw you write about, I guess it was late last year, late 2012, was about the paranoia surrounding the so-called Mayan apocalypse that we appear to have swept through no problem. I didn't even notice it. But I'm wondering, you commented in that column by way of comparison to the paranoia around the return of Halley's Comet in the early 20th century. And by way of that contrast, do you think that public perception of science and the paranoia that sometimes occurs because of the public's misconceptions of science, do you think that has improved, or do you think that that's gotten worse or stayed about the same?
I would like to see our perception of science take on a more historical sort of aspect to it, because we have been through these things before, as you quite rightly say. The idea that we were all going to be poisoned by cyanide from the tail of Halley's Comet in 1910, provoked some of this very, very similar reaction to this idea of the Mayan apocalypse last year. So by saying that these things have happened before, that we've been through similar events before, I think gives a context in which to understand what's going on at the moment. Science is a forward-looking subject. It's always about discovering something new, and perhaps what that new knowledge can give us in terms of technology. And yet, it seems to me as well that we with centuries now of history, with science, as we understand science, that we should be looking back as well and saying and drawing lessons and coming to conclusions based on what we've done before.
Beyond pointing out those historical comparisons, I think that is an effective way of providing some context. What are some other methods for compelling the public to think more critically about things like their Mayan fears, for example, or the Large Hadron Collider being turned on and creating black holes that will destroy the planet? Is there a effective antidote to all of that lack of critical thinking, or do you have to take it on a sort of case-by-case basis?
At one level, you have to take it on a case-by-case basis. At another level, I wonder, and I'm sort of I'm groping around a little bit in the dark here, as I'm still trying to form these opinions myself and sort of investigate a little more. But I'm starting to wonder whether the way science is taught might be part of the problem. And as it becomes more important about passing tests, so you can regurgitate facts or figures or equations or that sort of thing, perhaps what we're losing is the idea that science is actually not about the regurgitation of facts and figures, but it's actually about the critical investigation of nature. It's about curiosity, it's about skepticism, and it's about balancing those two things. So we see something in the world that we don't understand, and we ask ourselves, how do we investigate that? How can we try and reach a position of greater knowledge than we have in order to be more certain? Or at least, how do we deal with all the uncertainties that we have? And as I say, my thinking of this is in very, very preliminary stages, but I just wonder whether we can bring more about the previous investigation of the universe and science and the natural world. So tell a little bit more of the history of these investigations in our science lessons in order to show exactly how science is done and give people a feel for what it is and how easy it actually is to be a scientist, in the sense that you can ask a scientific question, that you can critically assess something that somebody has told you, not just believe it on faith.
Exactly. There's so much else we could talk about, but we're running short on time. So I hope you will return to join us here at the Star Spot, Dr. Stuart Clark. Yep. Certainly, if you have more books forthcoming, we'd love to chat about them. Thank you again so much.
Thank you very much.
Thank you for joining us at the Star Spot, Mind and Universe, continually expanding.
The Star Spot with Justin Trottier is an astronomy and space-themed podcast based out of Toronto, Canada. Please send comments or questions to starspotpodcast@gmail.com. The Star Spot is produced by Yingzhang Li, marketing and promotions by Natalie Morkos, guest news and voiceover by Amanda Gadke, research by Alexander Gurovich, web design by Blair Renault, graphics by Carmina Svillins. And I'm your host, Justin Trottier. Thank you for listening.